Yes, ma'am, but some of them didn't have sound. What do you mean that some of them didn't have sound? Which one didn't have sound, Jade? Of week one, right? Have you tried watching Doppler effect videos for this week? Okay, so you're saying the week one videos didn't have sound. Please, after class, please watch the week two as well, so I can when I go and tell him that you can't hear the sound, so he can fix maybe from week one and all the other videos that he has prepared, so to make sure that they all have sound. So please let me know, maybe text me privately and let me know if the Doppler effect like week two and week three have sound or not, so that we can fix that. Good morning, ma'am. Morning. I'm sorry I to be a bit late. Oh, okay. No problem. We're about to start now. We're about to start. You're not that late. So today we'll be doing Doppler effect. We're starting with terms two's work. So I hope you guys understood or took time with organic reactions that we did last week. And I hope you guys have an idea or you understand and you can tackle different kinds of organic reactions questions. Any question regarding the our lesson last week, the organic reactions? Did you guys get them? Did you try a bit practicing questions or not? And in the LMS system, there is the polymers homework and Doppler effect. So polymers was week one's homework, and Doppler effect is this week's homework. So the plastic and polymers you can submit on Thursday, and then the Doppler effect you can submit it because we have a lesson on Thursday. After the lesson, you can submit the homework on Friday. So the Doppler effect you submitted on Friday, and the plastic and polymers you can submit them on Thursday, so that I can see if you guys understand the work or not, if I need to go back and do that particular topic. So today, as I said, we'll be doing Doppler effect. What is Doppler effect? And I'll encourage you guys to go watch the pre-recorded videos before you go to class, so it gives you the theory behind that particular topic, like Doppler effect, because when you come to class we'll only be doing the questions only. So Doppler effect, let me zoom this so it can be more clear because it looks so small, so it'll be clear for everyone. Doppler effect is the change in the observed frequency of a wave when effect is the change in the observed frequency of a wave when the source or the detector moves relative to the transmitting media. What's very important to take note, so what I basically did in this slide is to summarize like the important keys, and I don't want you guys to only study through the summarized slides because you will miss what the theory have in the pre-recorded videos or in the other slides that are on the LMS system. I'll encourage you that go through all the work. When you come to the slides or when you come to class, you will only be dealing with questions. It will help you deal with questions or understand the questions better. So the important will do, ma'am. Sorry. Okay, please do that, guys. Most especially from next week, where we'll be doing work, energy, and power. Work, energy, and power is, it can be confusing if you don't understand the basics of work, energy, and power. You can confuse the theories that are there. Sorry for coming late. I got lost. Are you now in the right class? I hope you are not lost. I hope you're on the right class, and I hope so. Because this is physics grade 12. I hope you are in the class. What class are you looking for? Are you looking for physics grade 12? Is this CD? No, this is AC. And what class are you looking for? Guys, today is Tuesday, right? Yes, this is grade 12. The first class from 9:30 is the grade 12A to C. So this is physics, grade 12A to C. What classes are you looking for? I need the new timetable. Are you guys lost? What's going on? What class are you looking for? Ma'am, grade 10, like they gave us those in the newsletter. Ellie, yes, on Mondays we have physics at this time, but today it's Tuesday because yesterday it was a holiday. So today we're using the Tuesday's timetable. Where are you supposed to be on Tuesday at this time? Yes, guys, today it's a Tuesday, not a Monday. So yes, on Monday we're having physics at this time, but right now, today it's Tuesday. Yesterday it was a holiday. So we're using the Tuesday's timetable. I hope you, my bad, ma'am. Thank you. I got to find my right class. Have a good day. Please go find your right class. Please go look at your timetable. It's Tuesday today, not a Monday. But anyway, let's continue with today's work so we can cover as many questions as we can. Ma'am, okay, let me try. Can you see it now, Chloe? Is it better or must I zoom in more? Okay, so I was still saying that the most important thing to take note of with Doppler effect is the Doppler effect equation. You need to know this equation and the signs. You see, knowing the signs, like why is this negative sometimes, why is it positive, is very important. So you have your FL, which is the frequency of the sound that the listener hear, and then you have the frequency of the source that is transmitted through the sound source. You have V, which is the speed of sound in a specific medium. VL, you have the speed of the listener, and you have VS, which is the speed of the source sound of the sound source. So how do you know when is it negative and when do you know that it's positive? One thing you need to take note of is that when the listener is stationary, it means the VL is going to be 0. And when the sound source is stationary, it means that the VS is going to be 0. That's something to take note of, because in the question they can say that the listener is stationary, so you must just automatically know that VL is 0. And when the sound source is the one stationary, VS is 0. And another thing to take note of is that when the source moves towards the listener, VS, which is the speed of the sound source, is going to be negative. And when the source moves away from the listener, it means the speed of the source is positive. When the listener moves towards the source, VL is positive, and when the listener moves away from the source, it means VL is going to be negative. This is very important to take note of because it will really help you when you need to answer questions. Let's do some few questions today to see if we really understand the concept of Doppler effect. The first question says, any questions regarding the equations and the signs of the variables in the equations? Okay, let's do the first question. The first question says the hooter of an approaching taxi has a frequency of 500 hertz. If the taxi is traveling at... Okay, I need to move this. Will I be able to see everything? Not really. Oh, I can do this. What just happened? Okay. Okay, that's better. So everyone can see. So the hooter of an approaching taxi has a frequency of 500 hertz. If the taxi is traveling at 30 meters per second, the speed of sound is 340 meters per second. Calculate the frequency of sound that you can hear when A, the taxi is approaching you, you are the listener, and B, the taxi passed you and is driving away. So we need to calculate the frequency of sound when you hear the taxi approaching you and when the taxi is it has passed you already and is driving away. What is the first thing that you can do when you have like Doppler effect questions is to list what you are given. What are we given from the question? We are given the frequency of the source. What is the source? Is the hooter of the approaching taxi. That is the source of sound, where the sound is coming from. So we are given what Fs is, speed of the taxi, which is the speed of the source, which is Vs, to be 30 meters per second. And we are also given the speed of sound, which is 340 meters per second. This is the speed of the sound, meaning of the medium, which is the sound. So this is going to be our V. What are we missing? We're missing the frequency of the sound that the listener can hear. Meaning, what are we looking for? In both questions, we're looking for FL. And we know that the equation of Doppler effect is FL, which is the frequency of the listener, equal to, open bracket, the speed of sound plus or minus VL, which is the speed of the listener, and V plus or minus the speed of the source. All this multiplied by the frequency of the source. We are given what Fs is. We are given what Vs is. We have what V is. But what is the speed of the listener? What do you guys think? From the question that we have, what is the speed of the listener? Anyone? It is in the question because it's 0. Why? Because they're saying that the listener, we're not given any velocity of the listener, which means that the taxi is approaching the listener and it passed you and is driving away, meaning the listener is stationary in this question. So our VL, it's going to be 0, right? And for A, what is our equation going to be? We are told that the taxi is approaching you. The taxi is moving towards the listener. From this part, we know that when the source moves towards the listener, Vs is negative. So this is how you formulate your equation. So it's going to be FL. We know that we're looking for the frequency of the listener. Since A, the taxi is approaching you, the source is moving towards the listener. So V is going to be minus Vs, right? Let's identify what the top sign is going to be. They're saying that the listener moves towards the source, or the listener moves away from the source. In this case, we want VL. So the listener moves towards the source, or the listener moves away from the source. So which sign are we going to use for the top part? It's going to be positive. It's going to be V plus VL and Fs. So in this case, we know that this is going to be 0. So you just substitute what you are given from the question. And why is it positive here? It's because the listener is not moving. They're not doing any movement. So you cannot necessarily moving, but it is the source that's moving towards the source. The source is the one moving towards the listener. So VL is going to be positive. So you just substitute. You have your 340 plus 0 divide by 340 again minus 30, which we given from the question, open bracket. We multiply this by what? 500. And what answers are you getting for A? What answers are you getting for A? Anyone? The answer is supposed to be 548.39 hertz. So yes, that's the answer you're supposed to get, 548.39 hertz. And the B says, calculate the frequency of the sound when you hear the listener. The taxi passed you and is driving away. What is going to be the difference from A and B? It's going to be the sign in between, right? The B says A, it was the taxi. The taxi was approaching the listener. But B saying now the taxi has passed you and is driving away. So how do we identify the sign? Obviously, what's going to change in this equation is the sign of the speed of the source. And what is, when the source moves towards the listener, we said Vs is going to be negative. But now B says that the source is moving away from you, who is the listener, meaning Vs is going to be positive. Now we're going to use the same equation to calculate for B, but in this case it's going to be the frequency of the listener equals to, why is that a straight line, equals to open bracket V. The top part doesn't change because the listener didn't change the movement, or they didn't move. They're still standing in the same place, but we are told that the source is moving away, so meaning now the sign is going to be positive, Vs. So you substitute the same thing. You have your 340 plus 0, divide by 340 plus, now it's going in, b is going to be plus 30 multiplied by 500 hertz. And what answers do you get when you change the sign of the speed of the source? Yes, the answer is 459.46 hertz. So do you guys understand? Any questions regarding this? Yes, the answer is supposed to be 459.46 hertz. Yes, 46 hertz. Any questions regarding this question? No, ma'am. So do you understand how to work around the signs? And so let's just start the next question. Maybe you can finish it off. It says a person in a car traveling at 22.2 meters per second approaches a source emitting sound waves with a frequency of 400 hertz. What is the frequency of sound waves observed by the person? Assume that the speed of sound in air is 340. What is the first thing that you're going to do is to identify what you are given. A person in a car is traveling at that speed, and we are told that the frequency that is emitted from sound wave is that. So what is this? This is our frequency of the source, which is our sound. What is this? This is the velocity. I keep saying velocity. It's the speed of the listener. It's the speed of the listener, right? And we are given what V is. And what is the frequency of the sound waves observed by the person? What are we looking for? We're looking for FL. But listener, we're given the frequency of the source. We are looking for the frequency of the listener, and we're given speed. But we're not given what the speed of the sound source is. What does that mean? That Vs in this point is stationary. So it is equal to 0. It is equal to 0. So now, how do we identify it? A person is traveling in a car, and it approaches a source emitting a sound wave of that. So how do we identify our equation? We have FL equals to, we know that we have V. I'm gonna write it like this. So let's go here. We are told that the listener is moving towards the source. So meaning VL is going to be positive. And since the person is moving towards the source, meaning the VL is going to be positive, and since the sound source is stationary, it's going to be positive Vs. This is positive, and then you multiply it by Fs. So in this case, you just substitute what you're given. You have your 340 meters per second. You know the VL, the speed of the listener, which is 22.2 meters per second. Divide by 340 meters per second plus 0, multiplied by 410. Isn't it Vs negative? It cannot be negative because the source is stationary. It's only negative if the source is moving towards the listener. In this case, the listener is moving towards the source, not the source moving towards the listener. Do you understand, Jade? That these are two different things. The source is not moving. The source is stationary. Yes. It's only the listener who's moving towards the source. Hence, this is positive and this is positive. So you just substitute what you're given, and what do you guys get? What is the answer you're getting? So if the source is stationary, V else will always be positive. Yes. Yes. So what answers are you getting, guys? Anyone? Any questions, guys? Any questions? The answer you're supposed to get in this case after substituting what you're given is 436.77 hertz. Yes, 436.77 hertz. So that's the answer you're supposed to get for this question. I think for today's lesson we're going to end here, and I encourage you guys to go and watch the pre-recorded videos so that in our next lesson you will understand more of the next time we'll be doing questions only, and it will be easier for everyone to understand. So any questions, guys? If you have any questions, please feel free to text me, but our lesson will end here today so that I can start with the next lesson. So bye everyone, have a great day further. Thank you so much.